In this video, we're going to talk about using data presented in contingency tables to calculate probabilities. Now, we've talked about contingency tables in passing without any great detail already this semester. And in Unit 4, Chapter 4, there was a section on contingency tables. And I think, if I remember correctly, you had a quiz question that was related to contingency tables. So this should not be a completely new concept to you, but we really haven't done much with contingency tables until now. Contingency tables are a very useful tool for displaying nominal level data on two variables. It allows us to see the relationships between two variables. The two variables in this contingency table are age, whether the respondent is over 50 years of age or 50 or younger. The other variable is whether or not they have a Facebook account, how many Facebook accounts they have. There are three different values available on the Facebook variable: 0, 1, and 2 or more. In a contingency table, normally in the lower right-hand corner, the value will be the largest value that you'll see in the table, and it will represent the grand total. This 150 tells us that there were 150 people who provided data for this particular contingency table, 150 different observations. If we're just interested in the age variable, these are the column tables. We have 70 people who are over 50 years of age. We have 80 people who are 50 or younger. If we're just interested in the Facebook account variable, we can look at the rows and the row totals. There are 60 out of the 150 who had 0 Facebook accounts, didn't have a Facebook account. 70 respondents, or 70 people, had 1 Facebook account. And then 20 respondents had 2 or more Facebook accounts. Yeah, that's how we can read the table if we're just looking at one variable at a time. But if we want to consider both variables at the same time, we can look at the cell values. We have these cell values. There are 6 values in this particular contingency table. This cell value here tells us that 20 people are over 50 years of age and have 0 Facebook accounts. So we have the over 50 years of age variable represented, and then we have the Facebook variable represented. Again, 20 over 50 had 0 Facebook accounts. If we look at this cell value, that tells us that of people 50 years of age and younger, 30 have 1 Facebook account. Then we could go through all the different cell values and interpret each of those, but you should have the idea of what we're getting at. But what we really want to do, or where we're going with this discussion, is how we can use these values in a contingency table to calculate probabilities. We have our grand total. We can calculate a probability based upon the grand total. We can calculate probabilities based upon column totals or row totals. But let's go ahead and work through a few examples. And this is a problem from your book. I like the problem, thought I'd go ahead and share this one with you. Last month, the National Association of Theater Managers conducted a survey of 500 randomly selected adults. The survey asked respondents their age and the number of times they saw a movie in a theater. The association is interested in understanding the probabilities that an adult will see a movie in a theater, especially adults 60 and older. This information is useful for making decisions regarding discounts on tickets and concessions for seniors. How can they get more older adults to go to the movie theater would be one possible objective of this type of research. And as a result of this data collection, we have the contingency table that we see below. And we have 3 age groups: less than 30, 30 to 59, 30 up to 60, which doesn't include 60, then 60 or older. 60-year-olds go in this group. Then as far as movies per month, we have 0 movies per month, 1 or 2, 3, 4 or 5, and then 6 or more. But from these data, from this survey of 500 adults, the movie industry in general can make some important decisions on how they want to proceed with their marketing. With maybe they can attract 60-year-olds with different movie times. Maybe 60-year-olds would like 8 o'clock in the morning movies. Wouldn't be for me, but maybe some 60-year-olds and older would like that. But let's go ahead and look at some specific examples. What is the probability of selecting an adult who attended 6 or more movies per month? And this one's a pretty simple one here. We want what is the probability of an adult who attended 6 or more movies a month showing up in our sample here? And they're framing this, or the question is framing this, as if you were selecting a sample from this sample, what would be the probability of selecting an adult who attended 6 or more movies a month? So we look at the column 6 or more. Then we're interested in all ages. So we're going to go to this row total over here, 50. Go ahead and get our formula up here. And we look at 50 as the number of adults in this sample who had seen 6 or more movies in a month. To find the probability, we divide that 50 by the grand total of 500, and we end up with a probability of 10%. Let's look at another example. What is the probability of selecting an adult who attended 2 or fewer movies per month? 2 or fewer movies per month. So here we're going to have to combine the row data. We have 200 who saw 1 or 2 movies, and then 75 who didn't see any movies. So combine those two together to come up with this probability. And our grand total is going to, or the number of occurrences in the denominator is going to be our grand total of 500. Let me go ahead and get the formula up here. 275 over 500, and here's where we get the 500. Like I said, that's the grand total. Then our 275 is the addition of these two categories that we have here, 1 or 2 along with 0. So our probability here would be 55%. 55% probability that the adults surveyed saw 2 or fewer movies in the last month. Let's look at another example. What is the probability of selecting an adult who attended 6 or more movies per month or is 60 years of age or older? We've got 2 different focus events that we're talking about, and we're going to use the general rule of multiplication. So let's go ahead and bring up our formula representing the general rule of multiplication. We have the probability of 6 or more movies or 60 or older in age. That's what we're focused on here. So it's going to be the probability of 6 or more movies plus the probability of 60 years old or older. But there's a chance that we have overlapping events. We have events that aren't mutually exclusive. I mean, guaranteed you have events that aren't mutually exclusive in this particular example. So we need to subtract out the probabilities for adults 60 and over who also saw 6 or more movies per month in the previous month. So let's go ahead and plug in our numbers for this, and I'll go a little slower here and try to explain where I'm getting all these numbers from. Now, the probability of 6 or more movies, we're going to use our grand total in the denominator, 500. Then the numerator is going to be this row total, 6 or more. 50 is going to be in the numerator. 50 divided by 500, or 50 out of 500 is our probability. For our probability of selecting someone 60 years of age or older, we're going to look at the 60 or older column and use that column total in our numerator. Then in our denominator, we're going to use the grand total again. But now we need to find the probability of an adult that sees 6 or more movies a month and is 60 years of age or older. There is the number that corresponds to 60 or older and 6 or more movies per month. So that's where the row in this column intersects at 30. And we divide that by our grand total of 500. So now we work out the probabilities here. 50 divided by 500, 0.1. 175 divided by 500, 0.35. Then 30 divided by 500, 0.06. Now we do the addition and the multiplication. This is our probability of selecting someone out of these 500 who are 60 and older or have seen 6 or more movies in the previous month. All right, one more example using data from the contingency table. What is the probability of selecting an adult who attended 6 or more movies per month given the person is 60 years of age or older? Now this is a conditional probability question, with the condition being that the person they're focusing on or the group they're focusing on is that 60 year and older age group. But it's really a simple problem. We're interested in this column. We're only interested in people who are 60 or older. So that's all we really need to focus on. Now we are interested in 6 or more movies per month. So let's go ahead and draw a line here to represent that. So 60 or older, 6 or more movies a month, where the row and the column intersect, that's the number we're interested in. Only interested in 60 or older, so our denominator is going to be 175. Our probability of selecting an adult who attended 6 or more movies per month given the person is 60 years of age or older is about 17%. There's another way of wording this. What we could ask, what is the probability of someone 60 or older seeing 6 or more movies in a month? Now, to me, that's an easier way of wording it. It's more straightforward, but I'm trying to speak in the language of probability and statistical analysis using the proper terminology. Sometimes just common sense thinking about it is just as effective, if not more so effective. Again, this is an exercise in conditional probability with the condition being 60 years of age or older. All right, this will be our last example from these data. What is the probability of selecting an adult who attended 6 or more movies a month and is 60 years of age or older? And I'm going to do it the first way. I'm going to give you two alternatives as far as how you could solve this problem. The first method will be the same method that's used in the textbook. And for me, it's a harder method to answer the question that they're looking at. But let's go ahead and look at it. We're looking at the probability of selecting an adult who attended 6 or more movies and is 60 years of age or older. That equals, when we're looking for this probability, we're going to be multiplying the probability of seeing 6 or more movies in a month. Multiply that by the probability of the moviegoer being 60 years of age or older, given that they see 6 or more movies a month. Again, to me, that's way too complicated, and you'll see here in a second what I think is a much easier way of addressing this problem. But let's work with this for right now. We start plugging in our numbers. We need the probability of seeing 6 or more movies in a month. Our grand total is what we're looking at, the probability of all adults seeing six or more movies in a month. Our 50 here comes from the row total for 6 or more movies in a month. So 50 out of 500 represents this particular variable. Then for this variable, we're looking just at people 60 and older who went to 6 or more movies in the previous month. And that number is 30. And where these intersect, that's the one we're looking at. 30 ends up in our numerator. But for this probability here, we're controlling for, or our condition that we're working with is 6 or more movies in a month. So our numerator is going to be the row total for 6 or more movies in a month. We end up with 30 in the numerator and 50 in the denominator. Now all we need to do is multiply that out. We end up with a probability of 0.06, or about 6% chance of selecting an adult who attended 6 or more movies a month and is 60 years of age and older. Easier way. Let's look at it. What is the probability of selecting an adult who attended 6 or more movies a month and is 60 years of age or older? Out of the 500 adults surveyed, 30 are 60 and older and see 6 or more movies a month. Right there. We already know this from a previous example. We have 30 people who are 60 and older and see 6 or more movies in a month. Just divide that 30 by 500 and you've got the same probability. To me, that's much more straightforward, commonsensical. And as far as I'm concerned, if you see a problem like this on the exam, I'm fine if you use this method. You're probably making a good decision if you use the more straightforward approach. All right, that's it for this video where we've looked at calculating probabilities from data presented in contingency tables.